This is my compressor setup at the shop. It's a Quincy QT-54, which comes with a 5 horsepower single phase 3600 RPM motor. I got this off Facebook Marketplace. The motor was blown, and rather than order another 5 horse, even if I got an actual 5 horse single phase motor, I said, this is going into a building that has 3 phase power. I have a spare 3 phase motor. The 3 phase motor I happen to have is a 10 horse 1750 RPM motor. So obviously with the motor at half the RPM, if I wanted the pump to turn at the same RPM, I would have needed to double the size of the motor pulley. Well, I only increased the motor pulley size a little bit. I didn't double it. So this pump is running quite a bit slower than it was designed to run. And to my understanding, the only downside of running one of these pumps too slowly is that eventually the oil won't splash up and lubricate things properly. But I don't think we're in that territory. The other downside, of course, is it reduces or it increases the amount of time it takes to pump a tank full of air, the recovery time, let's say. So got this on there, and being a 3 phase motor, being an induction motor of any kind, the RPM is the same and the current draw is proportional to how much torque it's putting out, meaning that just because I'm running a 10 horse motor, it's not taking double the current of a 5 horse motor. It may be taking minimally more, but this thing is so lightly loaded, it's just going to loaf along. And actually, I should put an ammeter on here because I suspect it is not anywhere near the nameplate rated amps of 30 or 28. Yeah, it would be 28 amps fully loaded. So the other side of this that I had to figure out was of course, I ran all the piping. You saw my other video on threaded steel piping and iron fittings. And thank you for the commenter that clarified that it's steel piping, not iron. Thank you. But the other side of this that I had to figure out was the controls. So originally, these compressors come with a pressure switch that switches the motor across the line, right? So power comes into the pressure switch, power comes out of the pressure switch to the motor. 2-pole pressure switch, not going to work for a 3-phase motor. The other thing is these things, whoever spec'd that motor that was obviously not beefy enough because it burned itself up, also probably spec'd a pressure switch that was marginal, and you have to change these periodically. So I didn't want to have to do that. I wanted my pressure switch to control a contactor. And so eBay is a great place to find industrial controls used for dirt cheap. And so that's what I got. I got this thing that would be a few $1,000 new for a tiny fraction of that, let's say. And this is a combo starter, so that means it has the disconnect, chunk, and it's also got the, we'll leave that off, it's got the contactor inside. Is this a two-hander with my little my snap-on screwdriver? There we go. Okay, so inside here, as it shipped, was the disconnect portion, places for fuses, and the contactor. Now, when you get one of these, you have to check the coil voltage, and on mine it shipped with a 480 volt coil, which is not going to work, so you need a 240 volt coil, and you got to find one of these, so we changed that out. And then wiring this up, rather than the pressure switch controlling the motor directly, what the pressure switch does is control power to the coil. And then whenever that coil is energized, it pulls that main contactor in, switching the motor on. Originally, I had wired in just an on-off toggle switch in series with the pressure switch. Very redundant. I could just do this, right? But I wanted multiple remote switches, and I thought, let's make them all kind of uniform. So that worked, and I turn this on, then my air system goes off and on according to the pressure in the tank. At the end of the day, I turn this off. Then, because I like blinky indicator lights, and I think this one actually has a purpose, I wanted an indicator to be able to show when someone has left their switch on, so that, at the end of the day when we leave, somebody doesn't leave the compressor on and then have it start running when the tank loses pressure and, you know, for the weekend or whatever. So I wanted this light to be on whenever one of these switches was on. And originally I just wired the light. Actually, I got a little diagram here. So this is what I wanted. I wanted the indicator lamp to come on when any remote switch was on, whether the pressure switch was open or closed. And this is how I did it. So coil, pressure switch, remote switches, come off between those, have your 120 volt indicator lamp. And so I had to pull a neutral for that indicator. There's my neutral. And that worked, except that I noticed whenever the pressure switch would close, when the thing was calling for the machine to run, the indicator would come on, and that was because it was backfeeding voltage through the coil from the other side, and there was not enough resistance in that coil, obviously, to prevent this lamp from lighting. Or maybe there wasn't enough of the resistance. Something was happening. Something was happening causing this to be on. So after a little noodling about that problem, I decided to run the remote switches through another contactor, a little pilot relay, 2-pole, and my pilot relay would switch the pressure switch and you know, energize the circuit so the compressor could run, but the other pole of that relay would be for my indicator. Now if I use a relay with a 120 volt coil, a double pole relay with a 120 volt coil such as this one, then I can just hook this up and not need a transformer. But I only had one of these and I thought I wanted to save it because I am a hoarder. I have a bunch of relays with 24 volt coils and I have a bunch of 24 volt transformers. So I just made the secondary of that transformer feed the coil of the relay. The primary of the transformer is switched by these. And then our relay, one side is our pressure switch circuit going to the coil of our main contactor. The other side is our indicator. So here's how that works. You have to depress this, turn this on. All right, I'm going to turn my pressure switch off so the compressor won't run right away. And when I flip this switch or any of the remote switches, we hear the buzzing of the coil in the contactor. We have our indicator on. That's what we wanted. Now, if I close my pressure switch, which ordinarily we don't touch, I'll close that. Now I'll turn my switch on again, and you will see that thing switch to on, that contactor, not that thing, and you will obviously hear the compressor start. And then, of course, when the tank is up to pressure, the pressure switch will turn off. De-energizing the coil to the main contactor, but the pilot contactor, I don't know if that's the right term, it's the one I'm using, remains energized as long as one or more remote switches are on. So, anyway, there's my ridiculously complicated compressor setup. Maybe somebody can find a use in duplicating that kind of setup. The only thing remaining is I have an auto drain hooked up here, which I could leave plugged in all the time, but then it periodically just makes this sound. And if we're not using the compressor, we don't need the auto drain energized, so I'm trying to figure out a way to have a 120 volt supply only activated when the remote switch here is on. So shouldn't be that hard to do, right? It's not going to be, we've got a 120 volt 15 amp circuit. It's not going to have its own fusing unless I add something secondary. I can think about it, but that's a not as big of a problem. So anyway, there's that. Thanks for watching. Not happy vacuuming this time, happy compressing.